Alright, so this is the unit review. I'm going to start with number 1. So these are factor and cancel problems. Number 1 is it's already all multiplication. So remember, canceling is fancy division. So what we have to do is make sure we have multiplication happening so that we can divide, right? That's how we undo multiplication. So I'm going to use a little bit of exponentials here. We divide our big numbers. So if I do 96 divided by 54, and turn that into a fraction, I get 16 over 9. And then the rest of my terms here, exponent rules apply. So divide your big numbers, subtract your exponent. This really is x to the 5 minus 8, which is x to the negative third. And so that x to the third needs to go in the denominator. Similarly, in the new with your y's here, this is y to the 7 minus 4, which is y to the third. And since that's positive, that's going to go in the numerator. And that's your final answer. You can't do any more with that problem. Just a little warm-up, like stuff like that in Algebra 2. Just to remind you of those important. For number 2, we have a lot of factoring to do before we can cancel. So in my numerator, I have a difference of squares, a squared minus b squared. So I'm going to factor that difference of squares. A and B, opposite sign. Order does not matter. Factor. In the denominator, I have a sum of cubes. So a lot of you remember this as SOAP, but sometimes it's hard to remember what that pattern actually means. So I always do the A's and B's first, or if they're numbers, the numbers. So my pattern is A, B, A squared, AB, B squared. And then your signs are SOAP. So same, opposite, always positive. So the signs are SOAP. Your other pattern there, your A's and B's, that's something that you just have to memorize. Once we have this fully factored, and this is as far as we can factor, we can cancel. Because again, we can only undo multiplication with division. So what cancels is our A plus B's. So my final answer is A minus B over A squared minus AB plus B squared. Final. Factor, then cancel. Don't try to start crossing out things before you factor. Totally illegal. Out for jail for years. Let's get a couple more problems done on this, or at least one more problem done on this video. Alright, multiplication. So when you see a multiplication problem, the first thing to remember is that when you are multiplying, you do not need a common denominator. If you get a common denominator on this problem, it's going to make such a mess. So the nice thing about multiplication is what you really just need to do is factor and cancel. If you have a multiplication problem already, it's partially factored for you. So no common denominator needed. What we're really going to do is factor and cancel. I'm going to put some parentheses in already. That doesn't mean that these binomials and trinomials are fully factored. I'm just separating them out for myself. Okay, so in my first guy here, my x minus 5, that's already, like, there's nothing else I can factor from. So that's ready to go. Hopefully we'll find something to cancel with it, because that's what those problems about. 25x squared minus 1 is another difference of squares. 25x squared and 1 are all perfect squares, and there's a minus in between. So I'm going to set up my difference of squares here. The square root of 25x squared is 5x. square root of 1 is 1, and I need 1 negative and 1 positive, and that order doesn't matter. So my numerator now is fully factored. And when you see that multiplication sign, really, you can just put those parentheses in and make it all one fraction. With your fractions together. Multiply across. Okay, I'm going to keep factoring in the denominator. I have 10x minus 2. That binomial has a 2 in common, so I can GCF out a 2. And then when I divide both of those terms by 2, which you can imagine, or you can write in if you would like, 10x divided by 2 is 5x. Negative 2 divided by 2 is negative 1. Now I need to factor this trinomial. That's my last piece here. X squared minus 10x plus 25. It's a basic trinomial with a 1 in front, so I can go directly to my 2 sets of parentheses. I need two numbers that multiply to 25 and add to negative 10. And those two numbers are negative 5 and negative 5. Just a reminder that videos are super helpful, but use the video the way you need to. So if you need to pause so that you can factor in step 3, if I factored a step too quickly, pause the video and catch up. Or pause the video and get ahead and use it to check your work. That's a really good tactic as well. Alright, back to the problem. Now I'm going to cancel. So I can cancel an x minus 5. I can cancel 5x minus 1. And that's it. So just be careful that you make sure you capture everything that's left. So the only binomial left in my numerator is 5x plus 1. And what's left in my denominator, don't forget the 2 out here, is 2 times x minus 5. I almost never multiply out the denominator. I like that factored form. If you would like to multiply that to any absolute. Alright, let's get one more problem in here. Oh, it's a division problem. Let's get the division out of the way. Again, division is similar to multiplication in that you do not need a common denominator. Please don't get a common denominator. What you do need to do is take your second term and flip it and then make it into a multiplication problem. So since this is already written out side by side, I would go directly to flip and multiply. So I'm just going to recopy my first term here. We'll deal with factoring in the next step. Turn it into multiplication, and I'm going to flip. So my x plus 3 goes to the denominator, and my x squared plus 8x plus 16 goes to the numerator. And now I have everything in the right spot. Since this is a multiplication, I know I'm going to be looking for things to factor and cancel. Again, we can really just imagine that it's all one fraction now. Or you can write it as all one fraction. That is totally correct. And let's factor. Another cube problem. Here I have a sum of cubes. Here my a is x. The cube root of x cubed is x. And my b, cube root of 27 is 3. So just like with problem number 2, I like to write out the pattern first. Make myself kind of the little parentheses, try to balance some of my stuff will fit. So a, b, and my a is x and my b is 3. A squared, so x squared. AB, so x times 3, I'm going to write it as 3x if that's okay with you. And then 3 squared, and 3 squared is 9. And now your favorite part, so same sign, opposite sign, always positive. And that sum of cubes is factor. Next, I have this little trinomial to factor. It's a basic trinomial with a 1 in front, so I don't have to worry about split the middle. I can just put x's in front. And then I need two numbers that multiply to 16 and add to 8. And those numbers are positive 4 and positive 4. Go ahead and pause and see if you can get the denominator factored. Alright, hopefully you factored this trinomial. Again, it's another one just with a 1 in front, not trying to make things super complicated for you. I want you to work the fractions. So here, since I have a 1 in front, I can just do my two sets of parentheses. X times x gives me that x squared. And then my numbers need to multiply to 12 and add to 7. And the two numbers that multiply to 12 and add to 7 are positive 3 and positive 4. Order does not matter there. Last thing we have here is this x plus 3 string down. And now you can cancel your little heart out up here. I love it. This is my favorite part of every problem. So I can cancel an x plus 3. I can cancel an x plus 4. And that's it. Remember, with multiplication, order doesn't matter. So if you want to write the x plus 4 in front, you can. I'm just going to stay with the order that my problem has here. There's my numerator, and the only binomial left in my denominator is x plus 3. So, this first video is factor and cancel and some multiplication and division. Hopefully that was helpful. Keep watching the videos that you need so that you can get a good review and a good score on the first. Start strong.